Hello people, in this video I'll be solving third question from Leetcode contest, and this is 355 weekly contest. Okay, so let's read the question carefully. Maximum number of groups with increasing length. Okay, increasing length. Okay, you're given uses limits of length n. Okay, you have to create groups using numbers from 0 to n minus 1, and you have to ensure that each number I is used no more than uses limits I. Okay, the for any number I, you can use uses limits I times, like you have to find out the number given at that index, and that much of time you can use that number. Okay, to in a group, and each of the group should have different count, and in such a way that like each group must have a length strictly greater than the previous group. Okay, and the first one is each group must consist of distinct numbers, meaning that no duplicate numbers are allowed in a single group. Okay, so let's take this example 1 2 5. So if this is given, then what does it mean? So it means that number 0 is occurring one time, number 2 can be used 2 times. Similarly, number 0 can be used 1 time, number 1 can be used 2 times at because f index 1, and number 2 can repeat 5 times because at number 2 index we have 5 uses limits. After all this, like you have to create groups, and each group should have distinct numbers. Like you can just have in a group you can have 0, or you can have, okay, sure, or you can just keep 0 and 1. You cannot keep 1 and 1. Why? Because every groups should have distinct numbers. All numbers in a group should be distinct. So 1 and 1 not possible, 2 and 2 not possible, again 1 and 2 again not possible, because 0 1 has been used, and next to 0 1 we should have a group which is of length 3, not of 2, just 1 ahead of the previous. Like the length should be just 1 more than the previous length of the group. Okay, so what we can have is optimally what we can have is we can just use 2, and in second group we can use 1 and 2, and in third group we can use 0 1 and 2. Yeah, and then there are 3 groups, so the answer will be 3 in this case. I'm correct. Okay, then you can use 2 1 2. For 2 1 2, let's keep it as something like that. Yeah, so this is the optimal one. Okay, yeah, so I think you have understood the question. Now let's talk about constant also. So constant is, you can see the length of this numbers, like the numbers that are possible are 10 to the power 5, because like this number 0, 1, 2, that like that is represented as index, so that can go to maximum at 10 to the power 5. Okay, and then every number can be can have usage limits of maximum of 10 to the power 9. So every number can be repeated maximum of 10 to the power 9. So that has to be written as usage limits, but yeah, that values can go to 10 to the power 9. Okay, then let's understand these things using some, yeah. So here, so what should be the input for this? So let's, to understand the approach, I'll be going reverse. So this, for this the input will be 1, 2 and 3. Why? Index 0 repeating 1 time, index 2 repeating 2 time, index 3 repeating 3 time. Okay, and then how many maximum groups can be possible? So let's, what I'll be doing is just copying it here, and then maximum group will be, yeah, this one, and then yeah, this one, second group, and then the third group will be this. Okay, this is the third group. So here 3 groups are possible, and you can see in every group there are distinct numbers, and every group, every succeeding group has a length 1 more than its previous group, its preceding group. Okay, so it has length 1, it has length 2, it has length 3. You can see that. So for more clarity, I use, this is difficult. Okay, let's make this value as, yeah, this one. And again, for this, what should be the input? The input must have been given as 2, 2 and 2, 2, 2 and 2. Why? Index 0 is repeating 2 times, that is 2. Index 1 repeating 2 times, index 2 repeating 2 times. Okay. In this case, what can be the maximum number of groups? Let's find out. For this, okay, one will be this, second will be this. It's not second, it's kind of third. Okay, and what should be second? This will be second. Here also we are having 3 groups, but you know how it is coming, because in 3 groups we will be having, okay, yeah, this one, because in 3 groups we will be having uh, like one group will be having 1 length, second group will have length of 2, and third group will have length of 3. Similarly, for this, what should be the input? I think it's easy now. 1, 2 and 2. This will be the input, and here the groups possible. Check if we can create a group, like we can create 3 groups. So for that, what can be a greedy way to maximize the groups? So the greedy way will be to, like, not to use like list count in group of just list count. So think about it, how you can gridly distribute these numbers. Yeah, for that, let's see these two only. So to make maximum number of groups, if any number, if it is coming minimum number of times, that has to be in a group of maximum length, because 0 is like minimum count, it is in a group of maximum length. So 3 is the maximum length. Okay, and then 1 is second, 1 is having second highest count, so it is in medium length. Okay, and then 2 has maximum number of count when it is in maximum length. Okay, so that is the intuition behind my approach. So to satisfy this greedy selection, let's make it, it's not 0, it should be 2, because 2 kind of having maximum length, right? And similarly 1, okay, so to make a group of length 2, what we can do is we can create any 2. So I'll not pick 0 as of now, I'll pick just 1 and 2 for that. And then how you can create a group of length 3? I think you may not be able to create a group of length 3. So yeah, this is how it's looking. So, and to make a group of length 3, it's necessary that you must have at least 6 number of values. Here, how many values are there? 1, 2, 3, 4, 5. 1 is remaining. Why 6? Because, okay, let's write it in this. Okay. For level 1, you will just have one length. So it's 2 only. For level 2, okay, it's level 1. Okay, and then necessary count, just 1, right? And for level 2, we can just have, okay, let's make something interesting. Yeah, all this value can be anything, but it, at least it should have a count of 3. We are not going into the like distinct are there or something, but for each level we should have at the count which is given here. Okay, so for level 3 we should have at least necessary count should be at least 6, right? 1 plus 2 plus 3, 6, right? The same way it will go till level n. For level n, it will just have n into n plus 1 divided by 2. I think you can understand how we do 1 plus 2 plus 3 plus 4, something like that. Okay, so this is the same formula we are using. So this is something which I will use, and to make sure that distinct numbers are used, we will be utilizing second concept. The concept is, that concept is I have just discussed here. So the concept is, whichever is having minimum count will be used, should be used in uh, a group of maximum count. So if 0 is having minimum count, then it will be used in a maximum count, right? So this is one thing to note, and the other condition to note is this one. For every level we have some necessary count, and we must fulfill that count. So yeah, this is these are the count. So but so what I will do is, I'll just use these two conditions and I'll try to make a algorithm. Just think about it, how you can use these two conditions and make an algorithm. You can pause the video. You can pause the video here some time and you can think. Okay, let's come to the approach. So here, what we are doing is, first we are sorting usage limits to make sure that we will be traversing usage limits from minimum count to the maximum count. Okay, we are sorting it, and then what we are doing is we are keeping the necessary count. So how much count is necessary, that we are, for that we will be using it, and this will be the actual count. Okay, and then okay, I'm initializing the answer as 0. So whenever the condition will satisfy, we will be increasing the answer. Okay, so we will start from the minimum count, and minimum count should be there in the answer. If answer is something, then in that answer, minimum in that answer, any count, like any count which have been used earlier, so but will be used earlier, everything which is less, which has lesser usage limits than this or equal to this user limit. So if we are traversing for 1, 2, 3, 4, right? So you can see it has user count of 2, count of user limits of 2, user limits of 3, user limits of 4. So if I'm traversing this way, then if I am at this point, then everything before it is are having lesser count, right? So if I am at this point, so in answer, what we will have, everything, every number which is have lesser count, which is having lesser count, will be included in the answer. Got it? So if I am at the last point, so everything will be included in the answer. If I am at this point, so this number will be included in the answer. And to make up the answer, what we will be doing is we will be increasing the count. And how will we be increasing the count? What we are encountering. So if usage limit is ul value, some value, so that value will be increasing in the count. So okay, and then we'll be checking if that count is greater than or equal to necessary count, then we will be increasing the answer. And then again, if we have increased the answer, then we will be increasing necessary count also. So here there can, the one way to do necessary count is like, just we can have some index I is equal to 0, and here we can do I plus plus, not here, just I plus plus, and we can just have necessary is equal to I into I plus 1 divided by 2. This is to have 1 plus 2 plus, sorry, this is to sum up to till I, right? So the same thing we are doing here. Whenever we will be increasing the answer, that means we are increasing the level. So this means level, right? It's okay, I think you guys can understand, but to make code more sensible, let's return label only. Yeah, if we are understanding in this term, then let's take everything in this term only. Yeah, so this way, every time I'm checking and I'm increasing the label when it's above the necessary, and it's also making sure that we have lesser, all the values having lesser counts. So yeah, those two conditions, and this is the answer. Like, I think this is having time complexity of order of n. I think this should be minimum. And yeah, so guys, if you like this video, if you go to learn something, hit like,